so we're going to continue looking at vectors. Okay, most of what we do today is going to be numeric. It'll be a little bit of sketching, but we're going to focus a lot on doing numerical stuff. In order to do some formulas for adding, subtracting, and scaling, I'm going to give you two vectors. Okay, the two vectors are going to have horizontal and vertical components. When we do an actual problem, those will all be numbers, like that. I'm also going to use alpha. Okay, alpha represents a scale.
Always?
Yep, for what I'm going to do. Yep. What were the three things that can happen when you scale a vector?
It can get bigger, it can get smaller, or it can stay the same.
It flips.
Well, what are the three things that could happen that would change it? Yeah, longer, shorter, or flip. So we'll look at that. If you want to add two vectors together, okay, the old way that we added them together is we took a vector like that, we took another vector like that, and then we drew in the third side like that. Well, now, if we want to do it with just adding, if these are your two vectors, all you have to do is add this number to that number, and that becomes your horizontal for your vector. And then add the y value from that vector to the y value from that vector, and that becomes the y value for the new vector.
Did we do this yesterday?
Well, we did it visually, but we didn't do it with addition. So addition is very simple. You just add the two horizontals together, add the two verticals together, and that's your new vector. And that's without any sketches. Subtracting works the same way. If you want to subtract two vectors, the old way we did it is we drew a vector, and then we had to take the second vector, flip it around, and then put it on the end. Now, we're not going to do any of that. We're just going to subtract the x component from the first vector and the x component from the second vector. Then you're going to subtract the y component from the first minus the y in the second. When you're subtracting, does the order matter?
Yes.
Yeah. So if it says v minus w, then do the one from v first, w second. Okay, the next one is scaling a vector. When we scaled a vector before, let's say we took a vector and we did 5 times the vector. You would take 5 of them, you'd stack them all together, and that's how you'd show it 5 times as long. Now, we're going to think of this as being like a distributive property. So when you scale a vector, you're going to multiply the first number by whatever the scalar is. This is just a number. And then the second by that number. So you multiply each part of the vector by the number that's in front of it. So it's like a distributive property. And the last one is that symbol, which we talked about yesterday. What does the double bars around a vector mean?
How big it is.
And what do we call that?
The magnitude.
The magnitude.
Yeah.
Now it's not here anymore, but we had a sketch here yesterday. The vector 3, 4. Start here, 3, 1, 2, 3, 4. Okay, I want to find the length of that. I want to find the magnitude. Anybody remember what shape we made that into?
The right triangle.
Yep, made it into a right triangle by going like that. And this side's 3, and that side's 4. So how do you, you don't have to use those numbers. Yeah, you use Pythagorean theorem. So you take that number and you square it. Then you're going to take that number, square it, add them together, and take the square root. Okay, so that's the Pythagorean theorem. So that is the last formula. Take the horizontal component and square it. Take the vertical, square it, add them up, and then take the square root of that whole thing.
Okay, wait, do that.
So that's the Pythagorean theorem. So now let's, we'll try one of each one of those. Okay, so we did adding, subtracting, and scaling. We did that visually. Now we're just not drawing any pictures.
With the scaling and the Pythagorean theorem, that's only with one vector, right? Not like two different ones?
Right, when you are scaling, you don't need two vectors, you
Okay,
just scale
so,
one.
Like you gotta like do anything with that, but I get it now.
Nope. Yeah, adding you need two vectors, subtracting you need two, scaling you need one, magnitude you only need one. It's like when you take square root. You only need one number to take the square root. Okay, so here's the two vectors that we're going to work with. 2i plus 3j and 3i minus 4j. First thing I want to do is add the vectors together. No sketch. I don't want to sketch it. Okay. When we add the two vectors together, what's going to be the new horizontal component?
What?
5i.
I.
So
How
5i.
did you know you needed to do it in that form?
Well, they gave me both the I and the J and the other one, so we'll do the answers in both forms.
Oh.
Generally, I would stick with whatever form they give you. They won't give you both usually. So we got 5i
And then minus 1j.
minus, you can do 1j or just j. And what if you wrote it this way?
5. -1.
Negative 1. So either way, this is unit vector form. That's what our book called algebraic notation. Any question on that?
Can you leave it up for a second?
All right, so now let's try subtracting two vectors. So remember the old way, you take W, you'd have to flip it around and then put it on the end of V. Well, that's doing it as a visual. Now let's just use the numbers. If we subtract them, what's going to be the new horizontal component?
-1i.
Yep, you can do -1i or just -i. And the vertical. 7j. Yep, because it's 3j minus 4j. So that's one way you can write it. Or,
-1, 7.
in the angle brackets, -1 and 7. Okay. Any question on subtracting two vectors? All right. And what do we call that number in front again? The 3?
The scalar.
It's a scalar. Yep. So this is a scalar product. Could get longer, shorter, or reverse direction. You don't need which vector this time.
W.
Yeah, you're not using W. All you're doing is using V. So if we triple V, what's going to be my new vector? Let's start with the IJ unit vector notation. 6i
Plus 9j.
plus 9j. So to scale it, you're going to multiply each number in the vector by the scalar. So it's like a distributive property. 6i plus 9j. Or
6, 9.
6, comma 9. If you're going to write it with the angle brackets, you need to use a comma, and you do not put I and j. If you're going to write it without the angle brackets, you need a plus or a minus sign, and you need an I or a j. Okay, just don't mix the two.
Did you just pick up?
And the last one, you don't need W again. And we're going to find the magnitude.
So just need the
2
square root.
squared plus 3 squared?
So it's the square root of, let's look at x and y.
Square root of 3 plus the square root of 4. Square root of 2 plus the square root of 3.
So 2 squared
Plus 3 squared.
plus 3 squared.
So it'd be 4 plus 9.
So that would be 4 plus 9, which is the square root of how much? 13. So square root of 13. What's different about this answer compared to the
It's
three
not
that
a coordinate.
it's not a
Coordinate pair.
it's not a
vector.
yeah, none of these are coordinates.
Oh.
But these three are not, what did we just say?
Vector.
They're not vectors. Yeah, this is not a vector. That's a vector, that's a vector, that's a vector. The last one is just a number. Okay. So any question on adding, subtracting, scaling, or finding magnitude? All right. So what do you call a vector that's exactly 1 unit?
A unit vector.
A unit vector. So what we're going to look at for this one is if I give you a vector that's not a unit vector and I ask you to make it a unit vector, that means if it's too long, you need to shorten it down so it's 1 unit. Or if it's too short, you're going to have to lengthen it so that it's 1 unit. But the goal is to end up with a vector 1 unit long. Okay, so you're going to have to scale it. Let's say I gave you a vector that had a length of 5. What would you scale it by to make it 1 unit long? You would scale it by 1/5. If something was 5 units long and you scale it by 1/5, it becomes 1 unit. What if it was 8 units? You'd scale it by 1/8. What if it was
You'd scale it by 2.
half a unit? You'd scale it by 2. So what's the connection between the length and what you scale it by? It's the reciprocal. So what if you had a vector x units long? You'd scale it by 1/x. So that's the key. If you want to turn a vector into a unit vector, scale it by its length flipped. Scaling it by the reciprocal of its length will force it to be 1 unit long. So let's write that down. So to find a unit vector, if I just give you a random vector. So what we're doing is we're finding a new vector. We're not changing the direction of it. All we're doing is lengthening it or shortening it to force it to be 1 unit long. Yeah.
No, I was just gonna ask if we change the direction.
No, we're not changing the direction. All you can do is lengthen it or shorten it to make it 1 unit. So if you had, let's say you had the vector v, and you want to force that to be 1 unit long, you need to scale it by the reciprocal of its magnitude. That's the formula to turn something into a unit vector. Find the length of the vector, flip it, and multiply your vector by that, and it will make it 1 unit long. So you can write it like that, or if you want to put this together, you can multiply, think of it as like a fraction, 1 times v in the top, and then the magnitude times 1 is in the bottom. So this represents scaling a vector by its reciprocal, the magnitude flipped. If I give you a vector that's already 1 unit long and ask you to make it a unit vector, then there's nothing to do. It's already 1 unit long. But chances are, if I'm asking you to find a unit vector, it will not be 1 unit long. All right. So what's the first thing that I need to figure out to determine if that is a unit vector? What's the first thing I would have to calculate to determine if that's a unit vector?
Would you have to do the addition or the subtraction of it?
Well, what does it mean if something's a unit vector?
The vector is 1.
One.
What's 1?
The vector.
Right.
The magnitude. So that's the first thing I need to find. What is the magnitude of that vector? If it's already 1, then we're done. If it's not, then we need to fix it. Okay. What's going to be my formula to find the magnitude of V?
The square root of 3 squared minus, well, plus negative 4 squared.
What's 3 squared going to give you?
9.
9. And negative 4 squared?
16.
So that's the square root of 25, which is
5.
5. So is the vector that I gave you a unit vector?
No.
No. How long is that?
5.
5. So we have to scale it to shrink it down to 1 unit.
You scale it by 1/5.
We're going to scale it by 1/5. So that is what I need to figure out. What is V scaled by 1/5? Okay. So take 1/5 of the vector 3, negative 4, and think of it as like a distributive property. If you distribute 1/5 to shrink it down 5 times as much, what is going to be your first number? Three over 5. Yeah, 3/5.
And then negative 4 over 5.
And negative 4 over 5. So that is the new vector. And that vector is 5 times shorter than it originally was. So that means it's a unit vector. If you want to write it in the other notation, you can do 3/5 I minus 4/5 J. Okay, so any question on how we turned that into a unit vector? Okay, so again, key is find the length. If it's 1, don't do anything. If it's not 1, scale it by the length flipped. And that will force it to be 1 unit long.
Can you move it up for 1 second? Sorry. Can you go back up to that chart? Yeah.
All right, so the last question you're going to look at in 5.4 Part 1 is an application to velocity. So what I'm going to be doing is I'm going to give you a problem about an object being thrown, and you're going to figure out the vector. When you have an object being thrown, I will describe 2 things to you. First thing I'll tell you is the angle that the object is thrown at. So that angle is the angle to the ground. So if you threw something at like a 90-degree angle, that'd be straight up. A 0-degree angle would be perfectly horizontal. The angle will be somewhere between 0 and 90. Okay, always. So I'll tell you the angle it's being thrown at and the speed. Okay. So let's see if we can figure out a formula to write that information as a vector. Okay, so if we look at this particular object, if that was the vector for it, what direction is that object traveling in? To the left?
To the right up.
To the right and up. So it's traveling in 2 directions at the same time, right and up. In order to write that as a vector, I have to break it into horizontal and a vertical. There's 2 components. What shape could I make out of that that would allow me to break it into a horizontal arrow and then a vertical arrow? Yeah, we can make a triangle out of it. Just by going like that. visually, that is the horizontal part of the vector in black. The part I just drew in green, that's the vertical. I have to figure out a formula for the red and the green arrow, and that's the vector. You just have to figure those two vectors out. All right. So this would represent the angle that the object is thrown at. That's a 90. What would be a good name for that red vector since it's horizontal?
The horizontal vector.
How about a single letter?
H.
I. Oh, no.
A.
I would use X here. Just call that the name of the horizontal,
The Y.
and Y would be the name of the vertical. So you're going to be given this, and you're going to be given that when I give you the real problem. That's the angle the object is thrown at. That's going to be representing the speed the object is thrown at. Let's start with finding a formula for the red vector. Okay, that's the X. What side is X in relation to theta? Because it's right next to it. What do we call that side? That side is adjacent. And what do we call the side across from the 90?
Or
For the hypotenuse.
That's the hypotenuse. We are going to use opposite later, next. Okay, what trig function would involve adjacent and hypotenuse?
Cosine.
Cosine. So cosine of your angle equals the adjacent over. Now, when I say adjacent over hypotenuse, what do I mean by hypotenuse?
The velocity.
What, like the what of the hypotenuse?
the length.
The length of the hypotenuse. And what symbol do we use for length with vectors? What's the word that we use for the length of a vector more? I usually don't say length, I say magnitude. And what's the symbol for magnitude?
The two bars and then
The two bars, right? You put the two, when you want to know magnitude, you put the two bars. So that is what you should put here. Because when you write this, you want the length of the adjacent over the length of the hypotenuse. If you don't put the bars, then you'd be doing something like this. X over, literally X over an image. That doesn't make sense. You don't want to draw a picture in the bottom of your fraction. You want the length of the picture in the bottom of your fraction. So you want the magnitude. All right. Now, how would we get X by itself there?
Multiplied by
Multiply by what?
the magnitude.
The magnitude of E. Just multiply to move that to the other side. So the formula for the horizontal, for that red arrow, is the magnitude times the cosine. So when we write a velocity vector, that is the horizontal. That's the first part. Once we have the horizontal, what's the other part we need?
Vertical.
We need the vertical. So now we need a formula for the green arrow.
What's the I again?
That represents the horizontal.
Oh.
Yep, I means it's the left and the right.
Does J represent the vertical?
Yeah, we're going to have something with a J over here. I'm going to have a plus sign. Okay, what's the name of this side?
The opposite.
Opposite. What trig function would involve hypotenuse and opposite?
Doesn't that sign?
That's sine. So sine equals, opposite is y, And hypotenuse, how would I write what goes in the bottom?
Would it be
Divided. No.
the magnitude of V?
The magnitude of V, yep. If you don't put the double bars around it, just like I said before, you would actually be drawing a picture in the bottom of your fraction. What would that even mean? You're not drawing a picture of an arrow. You want the length of the arrow, and that's what that symbol means. Okay. So now, how would you move this magnitude over to the other side?
Times it.
Yep, times it, just like we did here. So magnitude V times the sine. That is always the vertical. So magnitude of V times the sine. And that is how you write a velocity vector. That's the speed that the object is thrown at. That is the angle that it's thrown at. So if you threw something at 90 degrees, it would be straight up. If you threw something straight up, would it move left and right?
Yeah. Or
No.
No. So if you threw something straight up, what's the angle for straight up? 90. Look what happens if you take the cosine of 90. 0. When you throw straight up, there's no horizontal. It doesn't move forward. It just goes up. Right? And what would be the angle for throwing something perfectly like straight in front of you?
180.
Well, 180 would be behind you. Would be like
360.
which-
Zero.
0. Okay. If you throw something at at a 0 degree angle, it doesn't go up or down. It's kind of like how a pitcher in baseball pitches. Right? You just throw it straight. It's a 0, usually pretty much a 0 degree angle. If you take the cosine of 0, cosine of 0, all the energy of the ball is going to go into this part because the sine comes out to nothing. There's no vertical at all when you throw something perfectly horizontal. Right? But usually the problem I give you, it's going to be a combination. It'll be a little bit at an angle. So it'll be between perfectly flat and perfectly vertical.
how do you account for like wind and stuff? Like I know in like golf, you always have to like earn like certain things. You have to account for like wind moving it. How would you calculate that?
So yeah, this formula does not.
Or like
account for
friction.
that. Yeah, it does not account for that.
How would you?
We would have to have a formula that somehow takes into account the material that the object is passing through. So if it's underwater and an object is, being shot underwater, that's a lot different than it's in air. So air wouldn't have as much of an effect as water, but you need something that takes that into account. And then you'd also have to take into account gravity.
How do you like calculate friction?
Friction and gravity. So that gets into a lot more physics than we're going to do. But physics, there's a known number. In physics, it's 9.8 meters per second squared. And that tells you.
Absolutely do that.
You knew that?
Yeah.
That tells you the acceleration due to gravity.
Alright.
So if you were going to take into account gravity, you'd have to have that 9.8 number in here somewhere. Yeah. And the formula would get a lot more complicated. So for our case, pretend like we're in outer space. We launch this object. There's no air. There's no gravity. Not near a planet. Just keeps going. So it's a very, very, very simplified formula. Okay, everybody have the formula? Okay, this is also the speed. I just didn't draw it over there.
Where?
Over here.
Okay.
And that's the same angle.
Alright.
It's just used twice. Okay, so we've got an object traveling at an angle of 30 degrees. So it's not horizontal, it's not vertical, it's in between the two. And it's being thrown at 50 miles per hour. Okay. what's the formula for the, let's start with the horizontal component.
Isn't that the speed, cosine, angle,
So that's the magnitude times the cosine. Put an I. And what's the formula for the vertical?
speed, sine, angle, j.
So speed times the sine of your angle, and put a j. Okay. Now just fill it in. What's the speed in this problem?
50 miles per hour.
50 miles per hour. And what's the angle?
30 degrees.
30 degrees. Okay, so we'll figure that out. That's going to be what we call the horizontal speed of the object. In other words, if somebody was throwing this object at you and you pointed a radar gun like straight at it, this is the speed it would be coming at you. It's not coming at you at 50 miles per hour. That's because they didn't throw it straight. They threw it up a little bit. So not all the energy is moving the object towards you. Some of it's going up in the air too. And now do the same thing for the vertical. 50 sine 30. So the vertical, that's the vertical speed. The vertical speed would be if you were, let's say you were in like a helicopter over the situation, and you pointed a radar gun straight down at the ball when it leaves the person's hand. That's the speed that it would be coming up at you. Okay. So one's vertical speed and one's horizontal speed. That's exactly what the green and the red arrows represent. Horizontal speed, vertical speed. Combine the two together, and that's your object being thrown. Okay. So first thing, I should make sure my calculator is in what mode for the angle?
Degrees.
Yep, make sure it's in degrees. Mine already is. So 50 cosine 30. The object is traveling horizontally, a little over 43 miles an hour. So like if you were throwing this object at a wall, that's how fast it's going to hit the wall.
Would this, when we do that, would this always come out in miles per hour?
Whatever they write right there. Yeah, so just whatever unit they have there. So the object would hit the wall at 43.3 miles per hour, and the object is going up at 25 miles per hour. So that would be like if you were above it in a helicopter and you pointed a radar gun straight down, that's the speed the ball's coming up at you at. And yeah, that's affected by gravity, but we're not going to get into it.
Is the I and the J just for vertical and horizontal?
The I is horizontal, and the J is the vertical. Yeah. Okay. Any question on that?
You just put it in and then you don't have to like add.
That's it. You're right. You're done. That's the final answer. And whether they want 1 decimal or 2 decimal places, that's up to the directions. Yeah. So that's called finding a velocity vector. Okay. Always use that formula and plug in your speed and your angle. And you need a calculator to do that. All right. Any question on that? All right. So let me give you a second to write this down. But I'm going to change a couple questions. Okay. The last thing we are going to look at, which is it's pretty straightforward, is called the dot product. So the dot product is a way that we can multiply 2 vectors together. We haven't done that yet. We've added 2 vectors together, we've subtracted 2 vectors, and we've scaled a vector. But we have not done a vector times a vector. All right. So when you do a dot product, I will give you two vectors, like, let's see if I have an example, like that. You'll have 4 numbers in those spots. The A1, the A2, B1, B2, all numbers. Now, if you multiply 2 numbers together, what do you get?
Another number.
You get another number. How about if you add 2 numbers together?
You get another number.
You get another number. So I want to keep that in mind. That is the formula for finding a dot product between 2 vectors. Very short formula. It's this number times that number, this number times that number, and then add it up. That's called a dot product. So we just said when you multiply 2 things together that are numbers, you get a what?
Number.
You get a number. Multiply 2 things again together that are numbers, you're going to get another number. And a number plus a number is a number. So when you do the dot product, the answer here is a number, like 6, 7, negative 10. So the dot product is just a number. The important thing is what we're going to do with that number. That's the last thing. All right, so let's see if we can find the dot product between V and W. When you write dot product, you do have to use that symbol, a dot between the V and the W. That's because when you multiply vectors together, there's 2 kinds of products. That is the symbol for a dot product. That is the symbol for a cross product. Okay, we don't do cross product in this class. We don't do cross product. Okay, we only do the dot product. All right, so let's see if we can find the dot product. So first thing you want to do is just kind of lay out that template right there. So following what we have up above, what would be the 2 numbers that go in those parentheses?
2 and negative 3.
So let's start with 2
Oh, 5.
and 5. So remember, the A1 and the A2 are the 2 numbers that are in front of the I. The B1 and B2, those are in front of J. All right, so we've got the 2 and the 5.
And then negative 3 and 3.
And then negative 3 and 3. What's 2 times 5?
10.
10. And negative 3 times 3?
Negative 9.
Negative 9.
So it'd be 1.
So the dot product here would be 10 minus 9, which is
1.
1. That's the dot product. So it's not really a hard thing to find. All right, let's try the other way. W dot V. If I do W dot V, how would it change what's in the 2 parentheses?
Flip it around.
So it would be
Negative 3. No.
Oh, it'd be negative 9 plus 10. No, 21.
well, these 2 numbers always go in the first pair, and these 2 numbers always go in the
It would
second
be
pair.
5 and then 2.
Right.
Yeah, but that wouldn't change the outcome.
So it would be a 5 and then a 2. So W comes first, then V. W, V.
So then 3 and negative 3.
And then 3 and negative 3. But what would the answer be?
It's
Still 1.
It would still be 1. So what does that mean when you can change the order
There's a six.
and you get the same answer?
This, what's it called?
That's called the commutative property. Yep.
Minus those 5 levels.
So the dot product is commutative. You can multiply and switch the order, and you still get the same answer. All right, let's try v dot v. That means you're just going to find the dot product of v with itself. It's like doing 5 times 5. It's the same number times itself. What would go in the first two parentheses if I do v dot v?
2 and 0.
2, it's like having a 2 and another 2. And the second set?
-3, -3.
-3, -3. And that gives me a dot product of
4 and 9.
4 and 9.
That's 13.
So 13.
13. Yep. Okay. Any question on that one?
No.
So we're going to do a couple more after, but any question on how we found the dot product in A, B, or part C?
Mm-mm.
Okay. We're not going to do that. Let's do example 2. So find the dot product. This time I wrote it without the I and the J. Okay. Still set it up exactly the same way. What's going to go in the first two parentheses? 2 and 0. And then 6 and 0. And the dot product there is 0. Yep. Remember, that's the number 0, not the vector 0. When you do a dot product, you always get a number. So that's 0. And when you get a dot product of 0, that means something.
What does it mean?
I'm going to show you what it means. Any question on finding the dot product there? Okay. Not worried about that. Okay. So the last thing that we're going to do is find the angle between two vectors. When I say angle, I mean like if you had a vector like that and a vector like that, I'm trying to find that. It's that angle between the two vectors. It's always less than 180. Right. Even if you draw your vectors like this, now you'd be looking at this angle here. Okay. So to find the angle between two vectors, it's going to use something that we've just went over in the last section. It uses the magnitude, and it uses the dot product, and that's equal to cosine. The reason there's a cosine on that side is because this comes from the law of cosines. But that's not, it's not something we go through in here. Okay, so it comes from the law of cosines. So to find the angle between two vectors, you need 3 things. You need the dot product, you need the length of the first vector, and the length of the second vector. You fill them all into that formula. And at the very end, you're going to have to get rid of cosine to get theta by itself. Anybody remember how you get rid of cosine?
Opposite.
Inverse.
Inverse, yep. So using inverse cosine is something you'll do in all these problems as the last thing. In case you're not sure what the denominator is, that's the length of u times the length of u. Or you could say magnitude. Okay, does everybody have the formula for finding the angle between two vectors?
Yes.
Okay, that's the point of the dot product. It helps you to find the angle. All right, so let's find the angle between those two vectors. Let's go like that. So we've got 4i minus 3j and 2i plus 5j. Let me let's use this. Yeah. Let's sketch those two vectors first, just to kind of get an estimate of what we think the angle is, then let's find it and see if it comes out to that. If I start right there, how would I draw vector u?
Over 4, down 3.
Which way is over 4?
To the right.
To the
Right 4,
Right 4, down 3.
down 3. So that is vector u. Now I'm going to start at the same point. How would I draw v?
Right 2, up 5.
Right 2, up 5. So we want to figure out that angle right there. How big does that angle look?
75.
75?
Oh, not 75.
120.
So
Yeah, 120.
if you kind of group it together and then turn it a little, makes it a little easier to kind of see it. Doing about like that.
Yeah, 120.
So it's definitely more than 90. Yeah, it might be like 100, 110. I don't think it's quite 120. 120 probably be a little more, but it's definitely more than 90. Any question why it should be more than 90? Okay, so let's find it. Okay, first thing I need is the dot product. How do I find the dot product?
4 times 2 plus 2, no, 3, negative 3 times 5.
Negative 3 times 5. Yep, so 4 times 2, negative 3 times 5. That's going to give me 8 minus 15. So that's a dot product of
-7.
-7. Okay, so that's the first thing we need. Next thing I need is the length of vector u. Okay. How do we find the length of vector u?
When we do the cosine sine thing,
No, we're not finding a vector, we're just finding a length. No, we don't need to draw it, we've got a formula for it. It was the 4th formula I gave you today. On the first page.
Minus cosine angle.
Yeah,
Isn't that just V over, well, not V, it's U? It's like U over then.
square root.
oh, plus y squared.
And what's the x in this case?
4.
X squared.
And negative 3 is y squared.
So negative 3 squared is
9.
9. So square root of 16 plus 9, 5. Yep. So that's the length of u. And what's the last thing I need?
The vector of v.
The-
We do the same thing with v.
I need the length of v.
Yeah.
Okay, so what's the length of v?
2 squared plus 5 squared,
So 4 plus 25.
which is 29.
Square root of 29. Okay, so now we've got all 3 things we need to find the angle. We just have to type it in. What goes on the left-hand side?
Cosine,
Cosine
theta,
theta. On the right side, you've got a fraction. What goes in the top?
adjacent. Well, the length goes on the bottom.
So the product of the magnitudes goes on the bottom. And what goes on the top?
-7.
-7. Yep, the dot product. And now I want to get theta by itself, so I want cosine to cancel out. How do we cancel out cosine?
Inverse cosine.
Yep. So we're going to take the inverse cosine of what's on the right hand side. -7 divided by, and you do want to put the bottom in parentheses. If you don't, it doesn't come out right. 5 square root 29. Just like that. And what did we think that angle was about? So when we do that, again, I didn't draw it maybe perfect, but it should come out. It says it's 105.07. That's the angle. Which makes sense with that picture. That looks right. 105.07. Probably there is a way to check that. I don't know how to check it, but it's 105. Okay. Any question on that?
No.
Now 105 isn't anything special. Okay, it's just a random angle. What do you think an angle would be? What do you think the angle would be, and we would consider it to be a special angle?
0.
0 is special. 90 and
180.
one more. 180. When two angles have an angle of 90 degrees, they are orthogonal. Okay, just another word for perpendicular. Means the same thing. But when you talk about vectors, that's the word they use. So two vectors that have an angle of 90 degrees are orthogonal. The nice thing about trying to figure out if vectors are orthogonal, and this is what I told you earlier, if you find the dot product between two vectors and it comes out to 0, you automatically know the vectors are perpendicular.
So would the same thing happen if we got 90 or 180?
So no, 90 and 180 is a little different. That's parallel.
Okay.
So we'll talk about 0 and 180. That's parallel.
Okay.
There really is no shortcut for that.
Okay.
But there is a shortcut for perpendicular. If you find the dot product and it's 0, you're done. The vectors are perpendicular. Okay. So the question here is, are these two vectors perpendicular? All you have to do is find the dot product. Okay. What's the calculation for the dot product?
2 times 1
Yep.
plus 1 times 2.
And if you add that all up, what do you get?
2. 4.
You get 4. Did the dot product come out to 0?
No.
No.
So it's not perpendicular.
So are these vectors perpendicular?
No.
No. What is the angle between them? Well, that I don't know. All I know is the dot product is not 0. If I wanted the actual angle, then I'd have to do what we did in the problem before. Okay. I got to go through the whole thing. So that's all you have to do to figure out perpendicular. Any question on that? So that's perpendicular. And the last one is parallel. Well, there's no shortcut for parallel. You just have to do the whole problem. And if the angle comes out to 0, that's considered parallel. That's two vectors like this. Think if you were throwing a ball, right, at a 0-degree angle, it's perfectly horizontal. Two things that are horizontal are parallel to each other. Or 180, you can think of it that way. 180 is still parallel. Remember somebody had said, what would 180 be? And I said that would be like you're throwing it behind you. Well, 180 is just the other way. But it's still parallel. So 0, 180. Okay. So let's determine if these two vectors are parallel.
So we have to do the whole problem.
You got to do the whole thing. Yeah. There's no shortcut for parallel. Okay, what's the first thing you need?
The dot product.
You need the dot product. What's the second thing we're going to need?
The length of V and the length of W.
And that's the third.
The dot product is 4 times 2. No. Yeah.
Dot product is 4 times
20.
20.
Whoops.
Okay.
Plus
Plus, don't forget that.
-5 and -28.
4 times 20 is
80.
80. What's 5 times 25?
That's a
5 quarters.
100.
420.
It's 4 quarters.
125.
125. So that's 205. So there is one thing I can say right now. Are these vectors perpendicular?
No.
No.
The dot product is non-zero. Are they parallel? I don't know yet.
We have to figure that out.
What's going to be the formula for length of V?
4 squared plus negative 5 squared.
Plus negative 5 squared, which
25.
is 25. Add those up. Okay, we get square root of 41. And how about length of W?
20 squared.
What's 20 times 20?
40. No.
Did you say 20 times
20 times 20. Like 2 times 2, but it has 2 more zeros.
400.
400. Yep. And the next part?
Then plus negative 25 squared.
So 25 times 25 is 625.
And then you add.
And then you add those up. What's 400 plus 625?
1,000.
1,025.
Oh, sweet.
Okay. Now we've done all the work we need to find the angle. We just have to set it up and type it in. What goes on the left side?
The cosine.
Cosine. And on the right side?
The 205 is on the top.
Dot product is in the top.
And then the other two are, the lengths are on the bottom.
And the 2 lengths are on the bottom.
And you have to put it in parentheses in the
Yep, and you need that in parentheses. When we type it in, what are we hoping to get for an angle? 180 or
0.
either one. That would mean it's parallel. So turn it on. Inverse cosine. Remember, second cosine, that's how you get to that. 205 divided by, and then open a parenthesis, square root 41. You don't need a multiplication sign between them if you don't want to put it. You can just type it like this.
Why would you do inverse?
And they made it.
We're trying to get rid of this cosine, so we're going to use inverse cosine. And then put 205 in the top, square root of 41 times square root of 1,025 in the bottom. Hit enter. And what did I get for an angle?
0.
0. So what does that mean?
Parallel.
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 Okay, V and W are parallel. So again, with parallel, there's no shortcut. You got to go through the whole thing. Okay, so let me change this.
Oh, where you? Oh.
So on page 352, there's 3 questions from what we just did. That's the dot product. And then the other page was 25 to 47. And 55 and 57. Okay. So there's not very much 352. That one's pretty quick. All right, so we'll take a look at that tomorrow. I will be after school tomorrow. Okay, that's because we have a test on Thursday.